Hey everyone, welcome back to the Maya Learning Channel. Today, we're diving into Dynamic Geometry Attributes, or DGA, and I'm going to show you how to set up your first tension visualization in Maya. Now, if you've ever spent hours trying to figure out why your character's shoulder is collapsing when they raise their arm, or why that cloth simulation looks wrong in certain areas, you know how frustrating it can be to diagnose deformation issues. You're scrubbing through your timeline, squinting at the mesh, trying to see what's happening. DGA solves this problem by giving you a real-time, color-coded heat map that shows exactly where your geometry is stretching and compressing. No more guessing, no more trial and error. You get instant visual feedback. And the best part? Once you understand the workflow, you can use this data to drive corrective blend shapes, fix skinning problems before they become major issues, and even export the tension data to your renderer for final output. So, let's get into it. First things first, open the Start Here file that contains a cylinder with a squash deformer already animated. You can download it from the link in the description. Now, before we do anything else, we need to disable cache playback. Go to the bottom right corner of your Maya interface and click the cache playback toggle to turn it off. Let's organize our workspace so we can see everything we need. Go to Panels, Layouts, and select two panes side by side. This gives us a split view. Make sure one panel is your perspective viewport and the other is the node editor. To set this up, go to Panels, Panel, and choose Node Editor. This setup lets you see your mesh in the viewport while you're wiring nodes in the node editor. It's a much more efficient way to work. Now, let's get our cylinder into the node editor. Click on the cylinder in your viewport to select it. In the node editor, click the Add Selected Nodes to Graph button. With the cylinder selected in the node editor, click the Increase Transversal Depth by 1 button a couple of times. What this does is reveal the entire network for the cylinder, including the original geometry and the squash deformer, which is exactly what we need to see. Now, you might have some extra nodes in here that we don't need, like this one and these. You can select them and click the Remove Selected Nodes from Graph button to clean things up. Just make sure that you keep the cylinder shape node, the original geometry, and the squash deformer visible. Time to create our DGA nodes. Press the Tab key in the node editor. A search box pops up. Type DGA and you'll see all the available DGA nodes. Select DGA Tension. This node is the brain of the operation. It calculates where your mesh is stretching and where it's squashing by comparing the original geometry to the deformed geometry. Press Tab again. Type DGA and this time select DGA Visualizer. The visualizer takes the tension data and converts it into colors you can see on your mesh. Before we start wiring things up, let's make sure Maya is ready to display those colors. Make sure that you are in the Modeling menu in the top left-hand corner. Open the Mesh Display menu and select Toggle Display Colors attribute. This tells Maya to show vertex colors on your mesh. Now open the Attribute Editor by pressing Ctrl+A. We'll be using this in a moment to configure our nodes. Alright, this is where it gets interesting. We're going to wire these nodes together. First, we need to see all the connection points. Click the hamburger button on the cylinder shape node to expand it. You should see attributes like Outmesh and World Mesh. Do the same for the squash node. Now, right-click on the DGA Tension node and choose Show All Attributes. This is important because by default, nodes hide their input connections. We need to see those to wire everything correctly. Let's make the connections. First, drag from the cylinder original shape node's outmesh to the DGA tension node's original geometry input. This gives the tension node a reference. It needs to know what the mesh looked like before any deformation happened. Now, drag from the squash node's output geometry to the DGA tension node's input geometry. Now, the tension node can compare the original shape to the deformed shape and calculate the difference. That's where the stretch and compression data comes from. Right-click on the DGA visualizer node and choose Show All Attributes. Okay, drag from DGA tension's output attributes to DGA visualizer's input attributes, and drag from DGA tension's output geometry to DGA visualizer's input geometry. The visualizer now has everything it needs to create that color-coded map. Click the hamburger button to open up the cylinder shape node. Drag from DGA visualizer's output geometry to the cylinder shape node's in-mesh input. This final connection sends the color-coded mesh back to your cylinder so you can see it in the viewport. And that's it. The network is complete. Let's clean things up a bit. Press A in the node editor to frame all your nodes. If you want, you can click the Layout the Graph button to organize them automatically. It's not required, but it makes things easier to read. Now, let's configure the tension node. Select the DGA tension node and go to the Attribute Editor. Set max stretch and max squash to 1.5. These values match our deformer settings and give us a better visualization range. If you set these too high or low, your tension colors won't be as informative. Also click Normalize Tensions. This gives you more consistent colors throughout the entire animation. Now let's configure the visualizer. Select the DGA visualizer node. In the Solo Attribute dropdown, choose Stretch. This tells the visualizer to focus on showing stretch data specifically. Make sure the Apply Color ramp is clicked. Without it, you'll only see grayscale values in your mesh. And now for the moment of truth. Select the cylinder shape node and open the Mesh Component Display section in the Attribute Editor. Click the Display Colors toggle if it's not already on. Now, scrub your timeline. Look at that! You should see colors on your cylinder showing exactly where it's stretching and compressing. This is real-time feedback. As you scrub, the colors update instantly, and you can see exactly how your deformation is behaving at any point in the animation. And this is just a simple cylinder with a squash deformer. Imagine using this on a character rig. You'd be able to see problem areas immediately. Shoulders collapsing, you'll see it. Elbows pinching, it'll show up in the heat map. So there you have it. You've just set up your first DGA tension visualization. This workflow opens a lot of possibilities. You can experiment with different tension modes, customize the color ramps, analyze specific areas of your mesh using component tags, and even export this data to Arnold for rendering. The key takeaway here is that DGA gives you visibility into what's actually happening with your deformations. No more guessing. No more hoping your corrective shapes are in the right place. You have data-driven insights right in your viewport. If you found this helpful, hit that like button and subscribe for more Maya tutorials. Drop a comment if you have questions, or if there's a specific DGA feature that you'd like me to cover in a future video. Thanks for watching, and I'll see you in the next one.